So today we're taking a look at two special properties in proofs, the addition and the subtraction properties. And they're going to be used to kind of build either segments or angles. We're going to take a look at both segment proofs and angle proofs with these properties. The first one is addition postulate. Basically, we're just adding, just an addition, kind of a statement in proofs used with both segments and angles. We're going to take a look at the way it works with segments for right now. So if A is equal to B and C is equal to D, then we get the conclusion A plus C is equal to B plus D. It might be a little weird. So think about it. If we have an equation and I add one quantity to one side, I have to either add the same thing to the other to balance it out, or I have to add something that it's equal to the other side to balance it out. So by taking A and adding in C, I had to either add C to the other side or what it's equal to, which is D. Now we have something called the segment addition postulate, a little bit different than just plain old addition. Segment addition postulate. I'm going to draw a picture to support this. So we have 3 points, A, B, and C are collinear, so meaning they're all on the same line, and B is between A and C. So B is hanging out somewhere there. And says then I can conclude if I have segment AB and I add to that segment BC, I'm going to get the entire segment AC. So basically the whole is equal to the sum of its parts, but dealing with segments. Same idea when we get to angles. So we have the angle addition postulate. And notice the difference in the statements. This top one was just addition postulate. The next one was segment addition postulate, angle addition postulate. Okay, so your point B lies on the interior of angle AOC. So I'm going to draw angle AOC. Point B is hanging out somewhere on the inside. We'll say point B is going to be right there. And it says, so all of angle AOB, that should be, I'm sorry, that's a typo there. How about all of angle AOC? Actually, let's try this. I have too many things. We're going to get rid of this equation right now. That's what we need. How about all of angle? Try this again. AOB plus angle BOC is equal to angle AOC, including that entire angle. So again, the whole angle is made up of the two smaller parts. Okay, so we're going to see how does this actually work using all this information. So starting off our proof, we have the given information. We know AB is equal to DE. We also know BC is equal to EF. I'm going to write that down as the given. And I already have it marked on your picture, but if it wasn't marked, I would make sure that you go and you mark it. So we see that this AB is congruent to DE, and we see BC is congruent to EF. Okay, and I want to prove the two segments are equal to each other. So the very first thing I would think, always tell you when you're using a proof, doing a proof, use what you have given first. First thing I would think is, well, I have these two segments, I could combine them. So if I take the segment AB, which is equal to DE, and I think I want to add equal quantities to each side, if I added in BC to one side, now I have to add something else to this side to balance it out. So I could either add in BC or add what makes sense to this picture, which is EF. So what we just did there was an addition statement. Plain old addition, nothing fancy. Just adding equal quantities to each side. Okay. Now there's not too much we can do. So what I would think is, well, what do I know about the segments? So if I take a look at that top segment, AB plus BC, I know if I put them all together, that's going to equal AC. And I can do the same with the other one. So if I know DE plus EF, I put it together, and that's going to equal segment DF. So what we just did there was addition, but it was that segment addition postulate. And remember, a postulate is a statement assumed to be true. You don't have to prove that. Okay, so now what do? Our goal is to prove AC is equal to DF. So I'm going to take a look at lines 2 and 3. So I see this information right here, AB plus BC, and I also see it again here, AB plus BC. So I could substitute back in line 2 this value, AC, instead of those two smaller parts. And now if I take a look at the other part of that statement, I have the same thing going on. Here's DE plus EF. Well, I know DE plus EF is equal to DF, and I'm going to plug that in there. And what we just did was a substitution. And with that, we have proven that AC equals DF. So those kind of 4 steps, doing an addition, doing a segment addition, and then doing a substitution, those are very commonly used steps, and they are repeated in many proofs. Okay, let's take a look at number 2, our angle addition. So same concept, it's just this time we are dealing with angles. Okay, so again, I'm going to write down my given information. I have the measure of angle ACD is equal to the measure of angle ABD. And we also have the measure of angle DCB is equal to the measure of DBC. So if I take a look, here's ACD is equal to ABD. And then I have angle DCB, so that's this one here, is equal to DBC, that's that one. Okay, so very similar in the way that that segment proof worked. We're going to pretty much do the same thing. So starting off, what can I do? I have this information. The only thing I can really do is piece them together again with that addition, plain old addition, adding equal parts to each side. So combining those two statements together, I have ACD plus the measure of angle DCB equals the measure of angle ABD plus the measure of angle DBC, and that was addition. And again, if I look at the picture, what that's basically saying is I'm taking these two smaller parts and I just added them. All right, I knew that they were here, I knew these two were here, that's why I'm adding those two together. Okay, so now I need to know maybe a little bit more about ACD and DCB. Okay, so angle ACD and angle DCB, well, that's equal to angle ACB if I put that all together. And I'm going to do the same thing on this side with these two. If I added them, angle ABD, and I put the other part, angle DBC, that's going to equal angle ABC. So what we did there with angles was an angle addition postulate. Basically, the whole is equal to the sum of its parts. Okay. So again, now we're going to use line 2 and 3, and I can see ACD plus DCB, that's the same thing down here. So what am I going to do? I'm going to substitute in what I know it's equal to when I put the two smaller parts together. So that's going to give me here in line 4, measure of angle ACB. So all I did was I replaced this information up here with what I know it's equal to. I'm going to do the same thing on the other side. So I'm going to take this information, which is the same as this information, and I'm going to replace what I know it's equal to. So I can say that equals angle ABC. And again, all we did here was a substitution. Two more on the back we're going to take a look at. And this is now dealing with the subtraction postulate. So pretty much the same thing that we took a look at on the front with addition, it's just I'm going to take two parts and subtract them. So if A is equal to B, C is equal to D, then if I removed C from one side, right, so I'm going to say A minus C, well, in order to balance out the equation, I have to subtract from B either C again, or what it's equal to, and in this case, it's D. Okay. So we have the subtraction of segments. So we're going to start with our givens. KO is equal to KP, and I have NO is equal to RP. Okay, so if we look at our picture, KO, the whole side here is equal to KP, and then I have NO is equal to RP. And what we're trying to prove then is the top two segments, KN and KR, are equal. So it's going to be very similar to how we dealt with this with addition. Okay, very first thing, if I take all of segment KO and I subtract out, let's say, NO, well, to make it equal to KP on this side, I have to subtract out either NO again, or how about RP, because that is what it is equal to. So just like with the addition, all we did was take this first statement and this first statement and basically combine them. But this time we were using subtraction. Okay. So we're going to go and actually build all of KO, just like we did on the front. So KO is equal to KN plus NO. And we're going to do the same thing with KP. So we can say KP is equal to KR plus RP. Just like we did on the front, that is a segment addition postulate. Okay. So if I'm looking at my proof statement, knowing where I'm trying to go, I know I'm trying to get KN and KR to be equal. That kind of drives my next thought. That tells me I want to figure out, well, what is KN equal to? Okay, well, if I'm thinking I can subtract an NO on each side and I would get KN, that's going to build my next statement. So now I have something that looks like KO minus NO is equal to KN. And I'm going to do the same thing on this side, knowing I'm trying to prove KR. I want to get KR by itself, so if I can remove RP from each side, okay, so I have KP minus RP is equal to KR. Okay, well, if that was algebra, I would say to you, what did you do? You would say, oh, I had to subtract. All right, well, that's what we did. So here's a different way of doing subtraction. So now I have KN, and now I have KR, and check out step 2. Step 2 has the same exact stuff here, right? And step 2 has the same exact stuff here. So kind of like what we did on the front, I'm going to use step 2. I'm going to rewrite step 2, but what I know KO and NO are equal to. So KO minus NO, I know that that's equal to KN. And KP minus RP, I know that that's equal to KR, and so all we did was a substitution. So they're very similar steps in all of these proofs. Okay, we have to combine them, we have to do probably a segment addition. Okay, in this case, we'll do an angle addition. We're going to take a look at this one, and I'm going to give you an idea, because sometimes doing proofs with angles gets a little difficult when we have all of these letters, and sometimes it's hard to find the parts. When you're dealing with the full angle, in this case, angle STE and angle WET, I'm going to suggest you leave it as such. STE is equal to WET. When we get to these two smaller parts, STW, so STW, let's name that a number. All right, and let's number this up here so we know what we're dealing with. WES, I can name that a number. I'll put that on the picture. It may just make it a little bit easier. Okay, so same thing with WTE. So look at what we're proving. We're proving WTE, that's this angle here, is equal to SET. SET, which is this angle here. So if we try this with numbers, everything's labeled, so now I can see how I've labeled it. This might make things a little bit easier in your proof, just to kind of follow along. Okay, so we have our first given, don't forget your second given, so I'm going to use the numbers that we replace this with and say angle 1 is equal to angle 2. And now just like we did up above, knowing that I have to get smaller parts, I'm not looking for a full thing, I'm looking for the smaller angles, only angle 3 and angle 4, I'm going to start by doing that subtraction. So measure of angle STE minus measure of angle 1 is equal to, so now I'm going to take this part and subtract either 1 again, or let's use 2 because I know that they're equal. Measure of angle WET minus the measure of angle 2. So there's a subtraction. Just like we did up above, we have to know how to build those angles. So we want to say, all right, well, what is our angle STE made up of? So STE is made up of angle 1 and angle 3. And if I look at angle WET, I can see that is made up of angles 2 and angle 4. So we did there an angle addition postulate. Knowing what we're trying to prove, again, kind of like we did in the one up above, I'm trying to prove 3 is equal to 4. I'm going to go back to this line and try and get 3 by itself, which I can by subtracting the 1 over. So if I have measure of angle STE minus the measure of angle 1, I'm left with measure of angle 3. So now I know what 3 is all about. We're going to do the same with 4 because that's what I'm trying to prove. So I have the measure of angle WET minus the measure of angle 2 is equal to the measure of angle 4. So again, there's a subtraction. And now, knowing what I'm trying to prove 3 is equal to 4. Well, go back up to your line 2 again. Notice what we have in line 2, STE minus 1. Here we go here, STE minus 1. So I'm going to take this angle 3 and I'm going to plug that right into that equation. So now I have measure of angle 3. And instead of calling it WET minus 2, I know WET minus 2 is really the same thing as the measure of angle 4. So I can say equals the measure of angle 4. And that is through substitution. So you can see these proofs are very repetitive. They have kind of the same process, same steps. These are usually smaller parts of larger proofs, but we have to be able to get the subtraction and addition concept down in order to use it in other proofs. So I hope this helped. We'll definitely do some more practice with this in class. Please make sure you make some notes and come into class with any questions that you may have. All right, have a great day.